Hi everyone, my name is Colin and I'm one of the maintainers on Griptape, an LLM framework here. And we just had our 0.33 release, which included a lot of cool features. And so I wanted to go basically just through the changelog line by line and walk through how you can use some of the new features, why some of the features were made, and why some of the changes were made, and just sort of explain what went on in this last release. So it's going to be pretty dense. I'm just going to go line by line and kind of walk through some examples, how we can use them, and hopefully we can learn some new things here. So start off at the top. Workflow input tasks and output tasks have been added. So these are two new fields to access the input and output tasks of workflow. So let's make a new example here. We'll do call it workflow tasks. Okay. So let's create a workflow. And we're going to import some tasks. So tasks go in structures like workflow. And we'll do a prompt task. And we're going to create a workflow here, and we're going to add some tasks. And we're going to add a couple different layers of tasks. So let's start by creating three sort of parallel tasks that are going to summarize into, they're going to boil down to a final summary task. So we'll start by doing, we'll create a prompt task, and a prompt task is basically going to interact with the LLM. So we'll do, and let's do some content. So we'll say we'll say categories equals, and we'll do like, I'll do trees, and sure, see what Copilot comes up with. So for category and categories, we're going to do that, and we're going to say write a poem about category. Okay. And then let's add a second layer to that, and I'll visualize this so we can see what it looks like in a bit here. And let's see, what did I do here? Okay, and now we'll say summarize the parent, or summarize yes. And we're going to insert here the output of those three ones. So we're going to do parent output text outputs text. I might need to look into that and confirm that. But so we've got a workflow here. Let me visualize what this actually looks like, show you what that looks like. So we can use another utility called the structure visualizer. So workflow is a structure. We can visualize structures. And this is going to give us a URL here, and we're just going to print that out. So let's run that. Let's see what this looks like. Okay, that gave us a URL. I'm going to copy that on my clipboard, and let's go over here and visualize it. Okay, so we've got three structures here, three tasks here. I forgot to give them names. So let's, we'll say this, the ID of each one of these is the category. And we also need to make these children. So we need to wire up the relationships. So the children, child IDs of this task is this summary task. Okay, great. So I run this again. Perfect. Trees, flowers, animals, landscapes, people, all summarizing here. So we can run this. I don't know if, let's see if this actually does anything. I think I've got the, I might have the summary task wrong, but that's okay. We don't necessarily need that right now. So I'm going to run that. So it runs those in parallel. It says write a poem about trees. It runs a bunch of poems. And the summary at the end, it says summarize this. I think this is parents output text. Let's try that one more time. And if that's not it, I'll move on, but let's see. Okay, great. So it did summarize all the poems. So basically it took all of these, each of these ran in parallel, and at the end it concatenated them all together, and I asked the LLM to summarize it. But now I want to get the output of it. So we can do that, or we can sort of inspect the workflow with these new properties. So input tasks and output tasks. So if we look at, let's print out the IDs of here. And we'll do ID, pass.id, and we'll do input tasks and output tasks. So now, we got some stray. There we go. We'll run that. So now we can easily see, okay, the input tasks are here, the output tasks are the summary one. So when you're trying to, the input tasks may be less useful, but it's nice to have. The output task is really handy though, because you've got this workflow with potentially many, many output tasks. In this case, we've got a singular one. It's really handy to have a single one, a single property that sort of gives you that value. So that's easy to wire up now. Okay, the ability to pass nested lists of tasks to structured tasks, allowing for more complex declarative structure definition. So that's actually what I did here in this example here. So you'll see this is previously tasks only accepted a single list, right? So you had to pass in your list of tasks, and that was all you can do. That made it really challenging to, if you wanted to do something like this, where you want to declaratively lay out of like, you've got this clump of tasks, which is sort of, your first layer, and then a second layer, you couldn't really do that. But now, because you can pass in lists of lists, you can do something like this list comprehension where we can easily layer in those different levels. If you wanted to build this pre this release, you'd have to do it imperatively. So you'd have to do something like flow dot. So you could do like input tasks, and you could do this. So, okay, so these would be your input tasks, and let's get rid of this. And then you'd have your summary task. And actually, we could keep our summary task up there. So you'd have to do it kind of backwards, right? You'd add your summary task because you can do that, but then you'd have to do for task and input task. You have to do this, and I think that would roughly give you the same thing. Let's see. Yeah, there we go. So it accomplishes the same thing, but now if you prefer declarative workflows or ways to lay out things, you can now just dump it all in the input there, and we'll flatten it out for you, and we'll take care of wiring up all the IDs. So kind of a nice change. Okay, next two, the Tavily and Exa web search drivers. So we'll do these. So we've got a class of drivers in the framework that are web search drivers. So this basically lets us connect to different web search backends. We support Google, DuckDuckGo, and now we've got Tavily, and Exa, which I believe are two sort of LLM-based web search drivers. So let's go to our docs and look at how we can use those. So I'll go over here, and we'll go to our web search drivers, and let's just copy one of the examples, and we'll look through it. So this uses DuckDuckGo. We'll use, let's copy this, okay? So we've got it, in this case, we're using our DuckDuckGo driver. We're giving it to an agent through the web search tool, and we're passing in DuckDuckGo here. But let's swap this out for, let's try Exa, okay? And let's see, what does this take? Takes an API key. I think it's going to load that in automatically, so we shouldn't need to do anything there. And let's just see what happens there. So I'm going to get rid of this summary too. We're just going to do the web search, and we'll try that. Missing. Oh, you know what? I need to install that. Let's just try and install that. It shouldn't. You won't need to do this yourself, but I think my dependencies are messed up. So we'll just add Exa real quick. Now let's try that again. Great. Okay, so the agent used the tool. This is a previous run. It used the tool. It got a bunch of links back. You'll see Exa in this case actually returns some of the scraped results. So we get that information right there, and we get those results back. So kind of cool. Tavily is the same. As anything in Griptape that's driver based, you really don't need to change your business logic at all. You would just swap this out your Tavily web search driver, and it would work all the same. You can also use these drivers directly. So we also call this out in the docs. So if we just created our driver out here, so driver equals that guy, and we can say driver search. Let's do trees again. And let's send that out. And I think this gives us a list of JSON. So we'll see what that looks like. Okay, there you go. So you get a list artifact that contains a bunch of JSON URLs. So if you wanted to use this directly and you didn't want to necessarily give it to an agent, you could use the driver directly. So two new features there, two new drivers there. Hopefully those are quite useful. Okay, workflow outputs to access the outputs of a workflow. So this actually is sort of related to the previous one. So I'm going to switch back over to that example, clear this out. So we've got our input tasks, we've got our output tasks. We'll just run this. So now the new property we've got is workflow.output. So much in the same way we had the output tasks, that'll give you all the tasks that are at the leaf of the workflow. Outputs will give you the values of each one of those. So whereas previously you would have to do, you'd have to do something like pass.output for task in workflow.tasks if task.children equals that, right? So this is how you'd previously do it. If you wanted to get all the output values, you'd say, okay, this is the output value. Do something like that. And you'd look at all the tasks. And if the task has no children, then it's a leaf and we know it's an output task. But now this simplifies quite a bit. So you could do output tasks. And now this would give you all the values of the output tasks. But we give this to you just through a new property. So outputs is effectively the same thing here. So let's run this again and see what we get. Okay, so it's formatted. It's a list that we're getting back. So and we've only got a single output. So we can just say, output in workflow outputs, and we'll just print out output value. So output is an artifact. An artifact in this case is it's a text artifact, and we really only care. It's got a bunch of information, but we only care about the value. So if we run that, then we'll get the value there. And sure enough, we get the output value. So again, just another convenience method for getting some of the values out when you have these complex structures. Okay, great. The base file loader, this is just sort of a hierarchical change. This probably won't impact any code you're writing unless you're creating your own loaders. But if you wanted to create a new loader that loads from a different file system, so maybe we support, for instance, like a local file system in S3. But if for whatever reason you wanted to create your own that parses some specific format, this is available to you. But again, this is kind of internal. Base loader, fetch, and parse. So a little bit of context that we'll get to in the change section. So loaders in Griptape have kind of gotten a redefinition of what they do and what responsibilities they play. So in previous versions, you would have something like this. You'd have a loader, and we'd have like a text loader. And in previous versions, a text loader, for instance, you would call load, and it was your responsibility to give it some text. So you'd say, like, this is my text this is just my text, okay? And what a loader would do, at least in the case of a text loader, is it would chunk it up. So chunking is the process of taking your text and doing what it sounds like, of going through and chunking it up into smaller bits, oftentimes for something like RAG, where you're putting in a vector store. So it would chunk it up, it would generate embeddings, also used for vector store, and then you could do things with it. In the case of a web loader, however, it was slightly different. So in a web loader, you would give it a website. So you would do like loader.load, and we'll do Griptape AI. So it's kind of confusing because a web loader, let's do loader and web. So a text loader took literal text, a web loader took a URL, and the web loader didn't do the chunking, but a text loader did. So it was kind of confusing. There was inconsistencies across the different types of loaders. So loaders have been changed in the regard that they all now take a source. So a text loader is really like a text file loader, right? So what it does now is much like a web loader, which loads from a URL, a text loader loads from a file. So we'll do foo.text and we'll say hello world. And now we can do .txt, and I don't. Let's see if that works with relative paths. I don't know if it will. And we'll ignore that for a moment. Let's see. Did text loader work? Web scraper driver. Let's get rid of that. Oh, I've got it backwards. So this is the web loader. This is the text loader. And let's get rid of that guy. Okay, I couldn't find foo.txt, so we need to get a relative path. Let's see if we can. We'll do this. And I always need to look this up. Okay, one sec. Python relative. Yeah. Okay, there we go. We'll do this. And foo.txt. Okay. Let's see if that works. Great. Didn't error. So a text loader, so it gives back an artifact. So we'll do this, and we'll do this. So we'll print out what the artifact is, and sure enough, hello world. So what has changed here is a loader is already it's more consistent with the other loaders. So a text loader or a web loader or a SQL loader, they all take a source, and they operate on that source in two steps. First, it does a fetching step, so it'll go to that source, get the data. It then does a parsing step where, depending on the loader, it'll do something slightly differently. But it takes the data from the source and converts it into a Griptape artifact. And so I say it does it differently because it really does depend on what the loader is. So for instance, a text loader doesn't really do anything with your text. It just takes the text, creates a text artifact, it just crams that data in and gives it back to you. A web loader, for instance, it's going to fetch by going to the site and getting the HTML, and it's going to parse by pulling out the body of it. So depending on what driver you have, as part of the web loader, it might do this slightly differently. But the key point here is that it's a two-step process. And what that gets us is it means that we can take advantage of the individual fetching and parsing process on our, if we've already got the data, we have the granularity to do one step or the other. So what I mean by that is, let's say let's clean up the web loader. We don't need that right now. And we'll keep this around because I'm going to forget it. So we did the load, and that does a fetch and then a parse. But if we just wanted to do the fetching process, let's actually look at what that would be. So you'll see fetch returns bytes to us directly. So we can, just look at here. What does this return? It's not an artifact, but it's just the bytes, okay? And then the parsing process, so in the case of the text loader, is going to decode that and turn it into text and then cram it in a text artifact. But we can also just do the parsing. So if we've already got the bytes, so let's file bytes, fetch, and now we can parse. And fetch. What are we doing here? We have the file bytes that returns that, and then this file bytes. That's that in there. And sure enough, we get an artifact at the end there. So, and let's confirm that is an artifact. Let's print that out. Perfect. So we get a text artifact. So this is handy if you've already loaded the data from someplace. Let's imagine in the case you've already got a web page. You don't necessarily want to use our loaders to go get that web page. You've already got it maybe in S3 somewhere. You could use, for instance, the text loader with an S3 driver to go fetch the data from S3, and then you could use a web loader's parse step to parse out that data. So you have much more control over the different steps. That happen as part of the loading process, and they're much more consistent overall. So hopefully this gives you more granularity. But if you are happy with the fetch parse process, you can always just call regular old load and we'll do that for you. But a bit more granularity there. So that's nice. So that's on the fetching and parsing. This one is mostly just a internal change. There's an encoding field. So the file manager, this should actually be file manager driver. File manager driver is used by file loaders. So like text loader, for instance, takes a file manager driver. By default, we default to local. You can specify other ones, and now you can specify an encoding field on that when you're using it. Base web scraper driver, extract page. So this is used as part of the parsing process. If you use a web loader, and when you call its parse, it will call extract page directly. But if you didn't want to use loaders at all, you could just call the web scraper driver directly, and you could call just the extraction. So on the web scraper driver part, we've split out again to be more granular, where now there's a distinct step between going and getting the HTML and then parsing out to get the body and the contents of the HTML. The text loader retrieval RAG module. So this is a RAG module that's part of a RAG engine in the retrieval step. Now takes a chunker because loaders no longer do the chunking step. So I guess I'll get to that a little bit later, but I mentioned it earlier, the loaders no longer do the chunking. And so now the chunking process has moved to different areas of the framework. So in the case of the RAG engine, you can now pass it to the text loader retrieval module, and it'll do chunking there. But I'll show a little bit about that a bit later. File new utility for getting the MIME type. So this is just handy if the loaders use this internally, but if you have any use for it, it's just a utility for getting the MIME type of a file. It will first look at the bytes of a file, and if you can't figure it out from the bytes alone, then it will suggest maybe trying to pass a file URL, and it'll look at the file type, but just kind of handy since there are some weird edge cases when detecting MIME types. Okay, a base Ruleset driver. So this is the cool one. A new class of drivers called Ruleset Drivers in Griptape. So let's show this one off. Drivers, hi. Okay, so we're gonna create we'll create an agent, and we'll create that agent. Okay, and we'll just we'll run it. Okay, and let's just make sure that runs. Okay, and we'll go hello. So let's add some rules, and we're actually going to add a rule set equals rule sets equals rule set. So rule sets are basically classes of groupings of rules, and rules are ways we can influence the LLM, so sort of steer its behavior. So if we create a new rule set here, let's fix this, and we'll give it, we'll call it personality, so we can kind of group together our types of rules. And we'll do this, and we're going to create a new rule. And we'll do here. And the value of this is a classic talk like a pirate. And let's add another rule in the personality class. That's always rhyme. So rhyming pirate, that's another personality. Let's add another one that's, let's say, like your output structure, for instance. So we'll do output format, and we want it to, um, let's say, always respond in, yeah, sure. All caps is good. Okay, so we've got one rule set that drives the personality. We've got another rule set that drives the output format, and then the rules in the respective one. So let's run this again and see what we get back. Ahoy there, matey. How be ye on this fine day in the sea of life? So not great at rhyming, but it got the pirate and it got the all caps. Maybe rhyming and pirate are at odds, but that's okay. So rule sets have historically been very tightly coupled with the code, right? So it's in the code, and if you wanted to pull these out somewhere, you would have to dynamically add the rule sets in yourself. But rule sets are a really great candidate for areas that can be moved out of the code because non-coders may be the ones who are tweaking the personality or tweaking the output of these agents. So now with rule set drivers, we can do that. So we're gonna add a new field here, and let's tweak the personality. So driver equals rule set driver. We're going to start by just loading them off the local file system. So let's import this local rule set driver. Local rule set driver. Okay. And how a rule set driver works is it is passed on a rule set and will load all of the rules from a source. So I'm going to get rid of rules because they're just going to get overwritten. I think they'll actually get merged in, but for now, we're just going to start with a empty slate. And the rule set driver, I believe, takes a directory. So let's do. Let's try creating a directory here. And I don't think we need this, but let's see. Okay. And actually, I'm going to pull up the docs as well here because this will be handy for me. Let's see. Is this in rule sets? And I think I may have a cached page here. Let's pull up the documentation locally. I know we have docs in this. Maybe it's not in the nav bar. Okay, so let's look up local rule set driver.py. Okay, so we need a rule set directory, a rule set path, and a place to store it. So let's do this. We're just going to copy this over. And this is going to sort of initialize our directory. So we'll do this is called rules. We'll call this personality and import a couple things here. And import OS. Okay. So this should give us a rule set directory. Import JSON. And this is gonna write some sort of basic data to it, and then we'll tweak it from there. So let's try running that. Okay, so it's still talking in all caps. That's okay. And we didn't specify the directory for the local rule set driver, but let's see what got written here. So let's personality.json. Okay, and format that. Okay, so we've got a local file. It takes a rules value. The value is always talk like a pirate. So let's add back our rhyming nature to it, even though that didn't quite. Let's change it a little bit. We'll do always talk like a pirate and always ask how I'm doing. Consider it pirate. Okay, and so we don't need to write this anymore. We don't need to make the directory anymore. We're done with that. But we've got the rule set path. So now we can pass this in. Their persistent directory is the rule set directory. All right, let's try this out. Rules not found with that personality. Oh, so the name of the rule, that's right. The name of the rule is basically the file name. So we'll do this. Let's try that. Okay, got it. So the rule set name, that sort of drives what the name of the file is, and at least in the case of the rule set driver. I'll show it in Cloud in a moment, and it's slightly differently, but you can sort of drive where it's loading it from. But you can see it loaded in from there, how you be doing, and let's just change that personality. And now we'll do talk like a robot. Hello, human. How are you doing? Very robotic. So now we've decoupled the code from the where the rules live. So that's pretty neat. But let's take it a step further and show off a different driver that is the Griptape Cloud rule set driver. So one of the things that Griptape Cloud provides is a set of a la carte APIs that are powered by drivers in the framework, where you can use various features like this. So in this case, we've got one for the Griptape Cloud, or we've got one for rule set drivers. So let's get rid of this. We'll do Griptape Cloud rule set driver, and we'll fill in some values there in a moment. The name in this case is actually going to look up to a value in Cloud. So I'm going to go over to Griptape Cloud. I'm going to go over to the rules section, rule sets, and I can create a new rule here, new rule set, and call it personality. This drives how the agent personality is. Okay. You'll see the optional alias for the rule set. So the alias is actually a way we can look up based on the name. So if we didn't set an alias here, the rule set driver takes a rule set ID, so we could pass around IDs, but it's easier for us to operate in human readable names. So let's do this, and we'll call it the personality melody. Give it the same as the name. And we don't need anything there. And actually, it looks like we need to add a new rule here. So we'll call this the robot rule. And we'll do this. Always talk like a robot. And let's do, we'll do like S. We'll do favorite food. Your favorite food is pizza. Okay. So we've got two rules there as part of a rule set. So we're looking good there. And so we've got this set here. We're not going to use our local rule set anymore. We're going to do this personality with a capital P. And let's get rid of this one. We don't necessarily need all caps anymore. Let's try running that. It requires an API key. Let's just make sure I've got that. And I think that's fine. I think I've got it called something else. So let's just manually pass that in. API key equals OS environ dictate cloud API. So the driver will automatically load in, I believe, this, but I've got it set as this. So we just need to pass it in manually, and that's okay. Perfect. So greetings, human. We loaded in robot, and pizza is my favorite food. So it was interesting. It just brought that up on its own. So now we've got the configuration of the rule set in Griptape Cloud. This can be updated via APIs. It could build a spreadsheet that updates this. But the main point is that our code is completely decoupled from the personality of our agent. So it makes it really easy for coders and non-coders to collaborate on an agent where the coders can focus on the business logic. You swap in a driver that loads the content as sort of the meat of it elsewhere. So that's Ruleset Drivers. Really cool feature. Let's go back over to the changelog. Alias. So, okay, yeah, the alias field has also been added on the Griptape Cloud conversation memory driver. So this is a different type of driver, in this case for storing conversation history. So let's tweak this one. We're just going to duplicate this guy and conversation. We'll save that. And let's tweak this a little bit. So we're going to import instead the, actually, before we do any drivers, let's just clear this out. And we're going to do a regular old conversation memory. So Griptape comes with a thing called conversation memory by default. So I'm reinstantiating it here, but this actually isn't strictly necessary. And what that means is Griptape will keep track of the conversation and replay it to the agent, so it remembers what's going on. So if I say my name is Colin, and then I can ask it, what is my name? And conversation drivers. We'll see. What is my name is Colin, and what is your name? Your name is Colin. So it remembered it. So that's handy, but that's only if by default it's only in the context of this Python run. So it's all kept in memory. But we can change that with conversation memory drivers. So I'll pass in a conversation memory driver here. And let's start with just a local one, so we can kind of see the values really easily. And we need to give it a persist directory where or persist file, and we'll just call it that. Perfect. So let's run this again. And let's see, that should have created a file called conversation memory. Perfect. So it created a new file with a number of runs. So when a structure is done running, it creates a run that has an input and an output. So the input was a text artifact. Hello, my name is Colin. The output was, hi, Colin, how can I assist you? And then likewise, the second one was, what is my name? Your name is Colin. So the nice thing about persisting this is obviously great for resiliency. It is persisted beyond just the duration of this Python execution, but it's also handy because we can sort of change around history a little bit. So if we say, hi, my name is Kyle, and let's fully change it. So now I can say, let's pretend I said, hi, my name is Kyle, and then let's pretend that the agent said, hi, Kyle. Now if we run it, we're still giving it that. So let's not do that. Conversation memory. And let's clear out this last one. So again, kind of rewriting this, and let's clear out this as well. So all the agent knows is the Kyle, and then let's ask my name and get rid of this. Your name is Kyle. Okay. So by changing the conversation, by having it persisted on a local disk, we can easily change it around and experiment with different ways of replaying the history back to the agent. So kind of handy. But local file system is only so useful, right? It's your local file system. So what Griptape Cloud provides is a Griptape Cloud conversation memory driver. And this has existed for a number of releases now, but the key thing here is it's easier to load in the previous run or the previous value. So again, I'm just going to set the API key here. And the new change here is there's a new alias field, which lets you set a human readable name. So we're going to do, we'll set this to Colin, and we're going to need to create a new conversation thread in Cloud. So we'll create a new one here, Colin, and we'll call it Colin. Okay, and that should be all we need. Let's try that now. And okay, it doesn't know who I am because I haven't told it. So we'll say my name is Colin. Nice to meet you. What is my blah, blah, blah. Okay, so went through. And then already you can see that we've got a few new entries in the thread. So in Griptape Cloud, we call it thread. That's basically a thread is a series of messages. And then Griptape, the framework, will map that into conversation memory. So at the very 0th index, we've got a message that says, what is my name? So this was the bad run, but let's go back to index 1. And then I said, my name is Colin. Nice to meet you. And then finally, what is my name? You mentioned your name here. So basically the same as the local, but now we've got access to it in the cloud. I can delete this first one because it's no use to us. So I'll get rid of that. And again, let's kind of rewrite some history here. So I'm going to get rid of this guy, and we'll go here, and we can edit this, and we'll say my name is, again, Kyle, and say Kyle. Okay, update this. Now let's do this. Name is Kyle. Perfect. So again, it's trying as much as possible to decouple the code from sort of the backend services behind the scenes. So it's extremely straightforward for something like an API to interface with the conversation memory or the threads API here. And the agent logic doesn't need to change because it's all driver based and we've wired it up here. So that was the driver. The key thing that came as part of this release is this alias field. And so this is really useful because what you can do is assign an alias for, let's imagine you were building a chat application. Your alias could be something that's like an internal representation of your users in your chat application. So if your chat application had your usernames as the unique key, let's say, alias in Griptape Cloud is a unique ID. It's just settable by you. So what you could do is you could set that to the user's username, and it'll automatically load or auto create a conversation memory instance and load in that user's particular instances. So this is nice to be able to have predictable control over which conversation memory you want to load in, and doing that through an ID you can set, in this case, alias. So super handy there. Okay. Um, Basic support for OpenAI structured output. So OpenAI a month or two ago added a feature called structured output, which basically makes it so the LLM will output it'll output JSON in conformance with a schema you provide. So they used to offer a mode called JSON object mode. And what that would do is it would guarantee that the LLM would output JSON. It wouldn't necessarily guarantee that the JSON was conformant to any schema you provided. So it was generally pretty good, but it was not guaranteed. OpenAI claims with this latest release that structured output actually will conform to it. So we can use it. I'm just going to copy this example since it's sort of wordy. And we'll do record output. All right. Okay. So we can use it at the prompt driver level. So we can remove this. We need to set the model to a relatively recent model. This is the one that they recommend, so we can set that here. We don't need temperature, we don't need seed. But the key thing here is response format. So this has always been here in Griptape, but it's just, again, changed slightly here, where there's now a new ability to set the type as JSON schema. So this is basically how you would do it if you were just interacting with the OpenAI SDK. So there's really not much wrapping going on here. And we pass it a JSON schema. Again, we need to provide this value of strict. We need to give it a name, and then we give it a schema. Griptape internally uses a library called schema, and we use this a ton to generate JSON schemas. It's a really handy way to produce, otherwise very wordy JSON schemas. You could use Pydantic if you already had that. Pydantic's got a way to do a model dump, which we'll convert it into, but either will work. It just takes a dictionary. And in this case here, we're saying we want it to output a CSS code as one of the keys and a list of relevant emojis as the string. And then we prompt it saying you'll be given a description of a mood, and your task is to generate a color code that matches it. And then we feed in the description. So the first description is blue sky at dusk. So let's try running this. Run Python structured output. Oh, that's the wrong one. And structured, that one. Fantastic. So we can see the output was, in fact, it looks like JSON. So at least currently, though, if we run this, let's print out the type of that. So you'll see it's a text artifact that comes back. So you got JSON, but it's still text. Griptape does have a JSON artifact, which takes care of some of this parsing for you. Right now, at least in this current release, we are not returning that, but we do have plans to sort of make this feel a little bit more native feeling. So Griptape has the notion of a JSON schema rule, which does something very similar to what we're doing here. So we can do, for instance, here, and we can do a JSON schema rule. And a JSON schema rule also takes a schema. So let's move this out. So we'll do this and put this up here. Okay, and this will pass this in here. And then let's get rid of this. So if we for a moment don't use OpenAI structured output, let's see what happens. We should get a similar answer. Okay, yeah, so we got a similar answer. But technically, this is less reliable. Okay, so the way the JSON schema rule works is it's basically under the hood, it's prompting the LLM in such a way that says, "Hey, use this schema and answer it." And for relatively simple schemas or relatively small prompts, that usually works pretty well. But it doesn't have that guaranteed schema conformance that the JSON schema feature does. Behind the scenes, what we'd like to do is make it so that if you use JSON schema rule and the LLM supports something like JSON schema, or if the other LLM support similar features in the future, we'd like to automatically do that for you. Right now, there are sort of two overlapping features, but that'll likely change in the future. But what I was getting at was you'll notice that the output is still text, regardless of which feature we use. That's another thing that's probably going to change in the future, where if you give a JSON schema rule and we detect that the LLM can produce JSON, then we'll just give you JSON directly. At least for now, it's still on you to parse it. So we got text here, but we can easily parse this out. And we'll do this. And let's print out the JSON. So let's see what that looks like. So we got we parsed out our JSON and that works there. So right now there's still that extra step there, and you have the guarantee that it will be parsable if you use the OpenAI functionality, but that's something we're looking at improving in the future. Okay, and finally, last one, the ability to pass callables to activity schema for dynamic schema generation. Okay, so for this one, we're actually going to need to create a new tool, and it's kind of a niche feature, but it enables some interesting applications here. So we'll do custom schema. And so what we're going to do here is kind of the usual. We're going to create an agent. We'll create an agent, and we're going to give him a calculator, a tool. And tools import. Well, let's just make sure tools work to begin with. Now let's do this and let's run it. ask it a super simple question that obviously it can answer on its own, but we want the LLM to use the tool just in case 2 plus 2 has changed. Custom schema. So we gave it that. It took an action, which was a tool action. It passed it in, and it used the calculator tool and did that. So that's cool and all. But let's now create our own tool. So as part of some of the changes that I can go over in a little bit, we can actually create tools inline. So the requirements for creating tools have been simplified a bit. Previously, you needed to create a tool directory. The tool had to be called tool.py. You had to create a manifest file. There's some interesting things that kind of structure enables, but we want those features to be opt-in, not necessarily the default behavior. So because we loosened up some of those requirements, we can just create tools inline here in the same file we're working with. So we're going to create, let's create, I don't have a cool name, but we'll call it a custom schema tool. It's going to inherit from base tool. And we need to give it, I'm going to use define, I'm going to import, we use adders, the library adders. So I'm going to use that here. You don't necessarily need to do that for a custom tool. And we're going to add a new field in a moment. But for now, let's just say let's do a random number generator. Random number generator. Okay. And we'll do get random number. And I guess 4 is a random enough number for now. And we'll do this. And so we've got our method. We need to decorate it with an activity decorator, which basically tells Griptape that this is a tool activity. So decorators import activity. And there's the activity. And that takes a description of when you'd use this activity. So can be used to generate a random number. And we need to give it a schema. So the schema is going to be, again, just a dictionary, or it's going to be using that schema library. So we're going to pass this here. And this, I think, is a dictionary. Okay, and we need to import schema. All right, so let's actually make this random. We'll do random, return random, rand int. Okay, and let's maybe say the upper bound. So upper bound, and that's an int. Actually, we're going to give that a description so we can use this literal, which lets us provide a description of what this field does. Description equals description equals, and this is the upper bound of random num. Okay. So it's a schema. It takes one field called upper bound. This is the upper bound, and we're going to pass this in. So we can do this. These are the params. There's a value in there, so there's always a value. And then from there we can plug out the upper bound, and we'll default to 100 upper bound. Okay. And let's give our tool that random number generator tool. Fantastic. This needs to be value. And we'll do that. Actually. Okay. I did a bad import here. So tools. And let's generate a random number between 0 and 5. Start running that. Oh, I got it wrong. It's values. Get that up. Five, it passed an upper bound, and we got 0 back. Okay, cool. So it generated a random number, so we passed that in. So this is just a regular tool. This is, again, the fact that we can create this inline here is part of the changes as of this release, so that's pretty neat. But really what's changed here is this schema field can actually be dynamic. So previously we used to be able to make things like the description dynamic by doing something like, um, let's do let's do description string equals, and we're going to make that a field, and we'll give it that default, make it a keyword only. And this is from attrs, so we need that field there. So we could do it like this, where we'd have access to this sort of special underscore self value. And effectively, what this would get rendered to is the description. Okay, so underscore self, we would insert that there. So when you're doing this Jinja rendering, it would be able to pluck values from there. So let's make sure that works. We can't actually see the schema, what gets rendered, but ultimately that would work. So that would change that there. The schema, however, so this particular field, until now, you couldn't have this similar level of generation or a dynamic nature of. So what we can do here is now schema can take a callable, in this case, a lambda. It also takes a self, and now we can return this value, and that'll be the rendered schema. So let's say if we want to upper bound of we'll do upper bound description. Okay. And now we can reference that here, self dot upper bound description. Okay. And now when we run that, so that will actually update the description. I guess this particular example isn't tremendously exciting, but behind the scenes, we're taking the values that are part of the tool itself. So in this case, like self, and now you have the ability to generate these schemas on the fly. So kind of a specialized feature. How we're using it internally is, in this case, the REST API tool. So this is the tool that we provide, where you need to provide schemas to the tool to inform it how to make the call to the backend, right? So you give the REST API tool a URL, and then you need to give it a schema on how to interact with that URL. What does the request body look like, right? Because that's going to be different per URL that you give it. So what we're doing is we allow you to pass in a schema, a custom schema, as one of these fields, and then the schema that's rendered down here is whatever you pass in. So we don't render one by default. We require you to pass one in. And that way we can have sort of a generic tool that is the REST API, but we let users pass in a custom schema. You might also want to allow, maybe not overriding the full schema, but we've done here overriding, changing a description, or maybe you want to change like the type. In this case, obviously upper bounds always can be an int, but maybe you want users to be able to flip between, like, is the schema type an int or a string or a float, right? So you might have some customization that would be useful there. So that's kind of neat. And that does it on the added features. So on changed, I'll kind of just go quickly over them. So the several classes, we just sort of standardized some of the fields on them. Before, there were things like it was named Bedrock Client or Pusher Client or MQ, and it was sort of named all over the place. We made it so now if there's a client, as we identify a client, it's just now named client. So a little bit more consistent as you're interacting with different drivers throughout the framework that oftentimes do include a client. So more consistent there. A couple renames. So we renamed pipe to pipeline, just to be more explicit about what it actually is. Remove the file manager default. Yeah, so this one, so previously the base file manager, again, this should be driver. The base file manager driver relied on loaders Now it's flipped around where loaders actually rely on the base file manager driver. So the handy thing about this is some of the features I mentioned earlier, where you can now have a text loader that is driver based. So a text loader could load a value from a local file system or S3 or some custom driver you make. So we flipped that around, and that's, I think, a better relationship. Loaders no longer chunk the data, so use a chunker to chunk the data. So this one is, we'll do this here, loaders, chunker. And actually, did we already kind of do this? Well, yeah. So previously how it used to work is you had a text loader, you would load your text, and you'd have some massive text here, and oops, that would be some massive text here. And how it would work is when you loaded this, the artifact that would come back would be chunked. So I mentioned earlier that chunking is basically the process of taking some text and breaking it up into smaller bits, usually for the purpose of doing something like RAG, you're uploading to a vector store. And so text loader would do this process for you. It's sort of magically chunk behind the scenes, whether you want it to or not. And then you would always be given back chunk artifacts. What has changed here now is text loader no longer does that. So that might seem like a loss in functionality, but you have more control over when that chunking happens, which is actually beneficial in some instances. So now text loaders, of course, take the path. Let's copy this stuff over here so I don't need to relook that up. And we'll do the file name. So it no longer chunks based on, or no longer chunks at all. So the artifact we get back here, value is just the artifact. So the hello world, we haven't chunked it at all. So now if you want to do the chunking process, you just import chunkers. So we've got a text chunker, and now we can create chunks by using the text chunker. You pass in the artifact and it'll give you chunks back. In the case of this text, there's really not much to it, so it won't actually chunk at all. But let's make that much bigger. Okay, that might be enough to chunk. We'll find out. And let's set we'll set the max tokens to 100. So this is basically how many maximum tokens it's going to fit in per chunk. So now let's run it, and we actually get a list artifact back. Okay, or rather a list. Yeah. So let's see, what do we get back here? Oh, we're not printing out chunks. So now chunks, and we'll print out the length of the chunks. Let's print that out first. So we got 32 chunks back. Each one is probably roughly 100 tokens, and from there. So now, again, the use case here would be oftentimes with like a vector store driver. So we could do something like this. Local vector store driver, and then you could upsert the chunks into there. So you could have your local vector store driver, upsert text artifacts, and you can give it a namespace, Griptape, chunks. There you go. So this would be, so basically, and we need to pass an embedding driver. We don't need to do this right now. But the key thing here is loaders used to do this. Now you do this as an explicit step, because you don't always necessarily want to do that chunking process, right? The chunking is very specific to RAG in this case. And so we've made it so that if you want to make that decision of, I want to do the chunking, that's something you explicitly do. Something like the RAG engine, which is a higher level abstraction, it will take care of the chunking process for you. It's just these lower level abstractions are less coupled together and you have more control. It's also more consistent with the other loaders. Like for instance, the web loader did not chunk, the SQL loader did not chunk, but the text loader did. So now everything's sort of on the same page. Loaders always go from a source, they fetch it, they parse it, and you give it an artifact. What you choose to do with that is completely up to you. If you want to chunk it, chunk. If you don't, you don't necessarily need to. So kind of a painful there change if you've already got code that relies on that chunking, but hopefully it's not too bad to migrate this, and I think it's a better long-term change. Okay, we kind of already talked about the loaders, how they take paths now instead of the actual content. Because of that, we removed some of the utilities with regards to loading files. We no longer need those. The data frame loader, that was removed. So we've got some steps for migrating in there in the migration guide. This particular extra is no longer needed because we now include the file type utility. So I mentioned earlier the utility for getting MIME types. We use that internally. We updated some dependencies, PyPDF, Redis, and Torch. We updated these main ones, and we removed the Torch extra from the transformers dependency. So this Torch, PyTorch, is a really heavy dependency that came with transformers, and oftentimes it's hardware specific. You need to sometimes install a version of PyTorch that is, for NVIDIA or AMD. And so there was enough nuance where with it where if you do need PyTorch, if you're doing like local image generation through something like Comfy UI, that's a separate step you'll take as part of the installation. Rename some methods here. So extraction, they take extract text and extract artifacts. So this is more consistent with other engines like the summary engine. So now those are just, again, more consistent. Some changes to how the extraction engine works. The fields a little bit more clear. So they now take fields as class fields instead of runtime arguments. This was a bit confusing and caused some weird bugs if you didn't pass around the right values. So for instance, if we look at the JSON extraction engine, you pass in the template schema into the engine now. Previously, you would pass it into extract arguments, and it was really easy to forget. And then behind the scenes, it would just sort of silently fail because you weren't giving it a schema. So now it's a bit more explicit where you're giving the schema. So that's the case for JSON and CSV. This is sort of an internal change, but it was technically a public field, so we mentioned it. One of the fields got renamed from all Rulesets to Rulesets. We renamed the Griptape Cloud knowledge base vector store driver. That mouthful is now just the Griptape Cloud vector store driver. So right now it's still only read only, but if you use Griptape Cloud knowledge bases, it effectively exposes a vector store you can query and use for RAG. The OpenAI response format is a dictionary instead of a string. So I showed that before. Just the payload has changed a little bit there, but what I showed with the JSON object, that's what you'll use now. This is an internal change as far as web scraping. It just includes more data, so that's handy. So media like blob HTML tags. Previously, those were getting stripped out. Now there's a little bit more information your LM can work with. This task inherits from prompt task. Again, mostly an internal change, but might be handy. There's just sort of a smaller surface area for Griptape to maintain, which is great. There are also instances where you might want to check of, is this a prompt task? And previously, this structure run task was sort of often a land of its own. But now, any functionality we add to prompt tasks, such as multimodality inputs, you can benefit from here. So that's nice. API clients are now lazily loaded. So something like creating the OpenAI client, for instance, in the OpenAI driver, it doesn't actually get instantiated till you use it. So this is kind of nice because you can create an OpenAI driver, or really any driver, mess around with the fields even after it's been created, and it won't create that OpenAI client internally until you actually use it. So this is nice for doing some sort of initial setup, in particular if you're using driver configurations. So we'll do this. And we'll do configs driver let's see, configs, import OpenAI. Let's see, do I have this wrong? Configs, drivers, import OpenAI drivers config. So this OpenAI drivers config previously was sort of eagerly instantiated. So as soon as you imported this, kind of all the values would already be set. So for all these drivers, right, like the OpenAI chat prompt driver, image generation, whatever it is. And so you couldn't really change the values of some of the fields like API key because those have already been loaded into the client. Now it happens lazily. So if you do something, you use the global configuration. So if you do this, you can now do like defaults dot drivers config dot prompt driver dot model equals blah, right? Um, and now that'll get updated and you can make whatever updates you want here, change the API key, and that'll all work just fine because again, it's lazy now. So sort of an internal change, probably won't impact most, but is a nice thing once you start getting into the fancier driver configurations. Upsert text artifacts, that gives you some data back now, which is nice. It returns a list of all the IDs you upserted. The local file manager work directory is now optional. File type, now core dependency. It's a really lightweight dependency, but it helps us again determine things like MIME type, and we've exposed a couple utilities to take advantage of that. So we really haven't added any bloat, but it added some niceness here. File manager tool uses file type for more accurate file detection, so that's great. We're not limited to just looking at file extensions. We can actually look at the contents of the type now. I mentioned earlier the base file manager driver. Encoding is a new field, and now when you call base file loader, so text loader or whatever, it will return a text artifact or blob artifact depending on that encoding. So just sort of an internal field that'll influence some behavior there. This is a handy one, structure.output. Previously, let's see if we can take advantage of an existing one here. Previously, you had a field called output, and this output field was either either an artifact or none. And in all instances of the workflow running or the structure running, it was always none, but our type system internally suggested that it could be none, even though that would never happen in practice. We've changed that now where it's always an artifact, so you don't need to do things like if workflow.output is not none, you can just access it directly. So if you're using a type checker like Pywrite, that'll save you some errors there and some type checking. Again, some changes to extraction engines. They now return more consistent things. It returns a list artifact of either JSON artifacts or CSV. So I mentioned the JSON artifact earlier. Now that's applied into the JSON extraction engine. And we're going to continue adding that in different areas of the framework going forward. So in like the structured output. Remove manifest. So this was talked about earlier. It allowed me to create that tool inline. It's just easier to create tools now, which I think is a great thing. An equivalent of manifest will come later as we explore, taking tools and deploying them to different platforms. But that will be an opt-in feature, and it'll take a slightly different form. So you don't need to worry about creating a manifest for now. And then finally, just some fixes. Anthropic had some issues with tool calling. We fixed that up. So now Anthropic native tool calling works quite well. There were some extra logs being thrown around. We don't need those. Previously, you could not set rule sets and rules at the same time. So if you set this on either a task or a structure, it would throw an error at you. Now you can set them both. We'll kind of merge them nicely. Realistically, there's probably not a ton of use cases of that, but you might want to have a named rule set, again, like personality, and then just some extra rules kind of thrown in at the end there. And those will get merged into what we'll just call a default rule set. So a little bit more flexible there. Prompt task will merge in its rules and rule sets. So this is if you set a rule on a structure and you set one on a task, it'll merge the two together, which is kind of handy. A similar behavior used to work in previous releases, but now with this, it works slightly differently. In practice, it won't really lead to any changes for you, but it's more flexible, which is nice. Prompt task not checking with the structure. So the implication of this is you can use tasks, these two changes, you can use tasks on their own. Again, maybe not, super useful, depends on kind of your workflow, but previously tasks were very tightly coupled to structures and you couldn't use a task without it. Some of the changes we made internally though are you can now, and it's called execute, you can run tasks on their own and you lose some of the things that the structure gets you. So it's not necessarily the best way to do things, but if you're just prototyping around, you can run tasks directly, and that works all the same. So you don't necessarily need to use a pipeline or agent, anything like that. So kind of a nice internal change. And that gets us to the end of the changelog. So this was a big release. This was a long video. I hope it was helpful in some of the regards and maybe you learned a thing or two. So thank you for watching or listening, and I will see you at the next release. Thank you. Bye-bye.